There are things we know we don't know, and one of the most haunting is dark matter. It may be slipping through you and me right now, invisible and untouchable, yet shaping galaxies. But sometimes, something even stranger emerges. An anomaly not hidden in the shadows of ignorance, but in the familiar data we thought we understood. One such anomaly recently appeared, buried in the icy shimmer of Saturn's rings. At the heart of this mystery is a revolutionary quantum processor named Majorana 1. Originally developed for studying quantum coherence and gravitational wave echoes, it was never intended to examine planetary systems. But in a daring experiment, researchers fed it archival data from the James Webb Space Telescope's atmospheric survey of Saturn. What it found defied expectations, and perhaps, the known laws of physics. Majorana 1 is not your typical data processor. Built through a collaboration between ETH Zurich and Fermilab, it operates inside a dilution refrigerator colder than interstellar space, below 10 millikelvin. Its qubits are protected topologically, encoded using Majorana fermions, exotic particles that are their own antiparticles. These special quantum bits are immune to many forms of environmental noise, making them perfect for detecting subtle, long-lived quantum patterns. What did Majorana 1 find? In Saturn's rings, it identified coherent subharmonic oscillations repeating every 28.5 minutes, synchronized across distances of over 100,000 kilometers. This wasn't just noise or statistical coincidence. These were persistent, structured patterns connecting distant sections of the ring system. Even more astonishing, the signal showed temporal asymmetry, suggesting, incredibly, that future ring configurations may have influenced past states. This aligns with a controversial idea in physics known as quantum retrocausality, where under certain circumstances, effects precede causes. No conventional instrument saw anything out of the ordinary. Spectrometers reported expected methane bands, ammonia traces, and ring composition consistent with past missions. But Majorana 1's ability to perceive non-classical correlations revealed something no one anticipated: a non-local coherent quantum signature embedded in the physical structure of the rings. And this pattern isn't constant. It waxes and wanes with Saturn's magnetosphere, strengthening when magnetic field lines align in specific orientations. This interaction between ice particles and Saturn's dynamic magnetic environment may create conditions suitable for exotic quantum effects, but no existing theory fully explains what's happening. So what could it be? One theory posits that Saturn's rings might be functioning as a macroscopic quantum resonator. The interaction of charged ice grains with magnetic and plasma currents could sustain standing wave patterns of vacuum energy, forming a kind of planetary-scale quantum circuit. Another idea involves Majorana quasi-particles forming within ring ice under extreme cryogenic and electromagnetic conditions. If certain ice particles contain topological defects, they might create stable domains where these exotic quasi-particles could persist, essentially turning parts of the ring into a natural quantum material. But the boldest hypothesis is rooted in string theory. Some researchers speculate the rings could be intersecting with higher dimensional brins surfaces in multidimensional space that, when they overlap with ours, might permit the leakage of quantum information. In this model, the rings become a kind of quantum transducer, capturing echoes from beyond the observable universe. Preliminary simulations have reinforced this idea. Under specific parameters, quantum vacuum fluctuations within the ring structure could become coherently amplified, similar to phenomena observed in Casimir effect experiments, but on a planetary scale. Critics argue the signal might still be a fluke, an artifact of the quantum processor or some as yet unknown data corruption. But the 7 sigma confidence level of the finding is extraordinary. In physics, that translates to less than 1 chance in a trillion of the result being random. And Majorana 1 was specifically designed to eliminate false positives by training on thousands of known and simulated anomalies, including gravitational wave echoes and black hole event signatures. If validated by follow-up observations, this could be a watershed moment in planetary science, and in quantum physics itself. We've long suspected that the fabric of spacetime harbors deeper secrets, but this might be the first time we've seen direct evidence of entangled systems on a planetary scale. The implications are profound. Could planetary bodies act as quantum beacons? Could large-scale natural systems, rings, magnetospheres, even moons, harbor hidden channels of quantum information? Could they serve as cosmic instruments, revealing the music of the quantum realm not through electrons, but through entire celestial structures? One thing is certain. Saturn's rings are more than frozen debris. They may be vast, delicate instruments resonating with signals from the deepest layers of physical law. Perhaps even from outside our spacetime altogether. And somewhere in the silence of those frozen arcs, the universe may be whispering to itself, in a quantum language we are only just beginning to decipher.